We talked about the scale factor already, and it may be on page 87, before we did the transformations. And we had our scale factor, we called it K, and it was the new length of some shape over the old length. Or we rearrange this based on our needs. When we need to calculate the new length, it's the scale factor times the old length. Then we did some calculations and we had some fun, we laughed, we cried. It was good. Well, no one cried, but wait. This time. Now we're going to ask the same question, really, but seeing what happens when we talk about area changing. Area changing. And that puts us on page 91. Scaling area. I'll just do it by way of exercise 12.3. This exercise isn't what a quiz question is going to look like, but it leads me to how I should view length scaling and area scaling, what's similar, what's not, and so on. I have a 50 by 25 rectangular field. Put it over there, maybe like that. So 50 meters, 25 meters. And the boundaries are increased, or the side lengths are increased by 50%. So that means, this is the original, I'm going to get a new rectangle. By increasing the side lengths, this guy is going to go up 50%, this guy is going to go up 50%, and we'll do the calculations in a second. First of all, what is the scale factor that I'm actually going to use to find the new side lengths? When they say an increase of 50%, what is the scale factor that we use? 1.5. All right. So even though they give me information about, in terms of percentages, I need to convert it. Then we want to know what is the area of the new field. Let's do that first, changing the question a little bit. In order to see what the increase is, I need to calculate what is the new dimensions, what's the new area, so let's do that. So this guy over here is now going to be 25 meters times 1.5, because that's my scale factor, to give me 37.5 meters. This length, the horizontal one, is going to be 1.5 times 50 meters to give me 75 meters. So now my new rectangle has dimensions 37.5 and 75. Obviously bigger. And each side length has increased by 50%. So my old area, the area of a rectangle is the length times the width, 50 meters times 25 meters. And I get something that you get. Does anyone want to share what they get? 1250 meters squared. And then, of course, I have a new area, which I calculate in the same way, 75 meters times 37.5 meters, and I get something a little less obvious, but straightforward calculations. What do I get? Is there a decimal? No? 0.5? Square meters. Okay, so the area obviously increased, which it should. Now the question is, what is the percentage change in the new area from old to new, and what can I observe? So percentage change in the area is new area over old area, and I want to make it a percentage, so I'm going to times it by 100 to get the percentage, of course, an increase, which we can see. What is that percentage when you calculate new over old? So your new is 2,812.5, your old is 1,250, then times 100, and you get a number. 225%. So we see that, let me zoom out a little bit. The side lengths increased by 50%. But the area, as a result, increases by how much? 225 is the end result. The increase is from a base 100, which means it's 125% increase on top of the original triangle. So it's more than double. Even though the side lengths only increased a little bit, the side lengths didn't double, but they double the area in the end. So the area changes in a different way than the side lengths do. It's not the same proportional change. What happens if I just calculate this and forget the percentage portion? Don't multiply by 100, I just calculate new over old. That would give me what I'll call the area factor. New area over old area. Something very similar to the scale factor, but that was with length, so I can't call it the scale factor again. I'll just call it area factor, just to be able to distinguish between the two. Now this and this, they're all the same. What is the number that I get? Forget the percentage aspect. Just calculate a scale factor, but now it's for area, so I don't want to call it scale factor. Let's call it the area factor, just to be different. What do I get? 2.25. 2.25. Now, what is the link between this and the scale factor, which remember was 1.5? What is the link between these two? It's not random. There's a very specific connection between these two. No. Forget percentages. Percentages are only for a presentation at the very end, if a question wants to. What is a calculation link between 1.5 and 2.25? I heard it. I hear everything. It is the square. 1.5 squared is 2.25. So the scale factor squared is the area factor. Does that make sense? It does if you zoom in and look at how the new area was calculated.
Is that going to be everything?
It's going to be every time. Because this 75 came from 1.5 times 50. This 37.5 came from 1.5 times 25. So there are two of them multiplied in the new area. So 1.5 squared. So this question is trying to lead me through and try to get me to see why a little bit the scale factor and the area factor are linked in this way. But now once I know that, I can use that. It's always going to be the same. Okay. So that means we can also write the new area is the area factor, which we can write as k squared, times the old area. So when I talk about scale factor, I'm talking about a change in the length dimension, side lengths. That's the scale factor. When I talk about a change of areas, that factor, that we'll call the area factor, is the scale factor squared. Any thoughts on that? I guess it's kind of funny. Yeah.
So when would you use this when you're trying to find
In the next question. We now have to see what are the questions going to look like and how do I use this. We want to run through all the possibilities so that there is absolutely no surprise in the quiz. So if you like your quizzes full of surprises, then don't listen. Because after this, there will be no surprises. You were warned. I'm going to spoil it all because we're going to run through all the possibilities. Exercise 12.4. The area of a shape, whatever shape, is 100 centimeters. So that's the old area, 100 square centimeters. If you want to design the same shape with dimensions 20% larger, some questions follow. So I want the side lengths to increase by 20%. So a length dimension increase by 20% means the scale factor is 1.2. Because I can, but I'm not going to use a percentage in any calculation ever. I need to convert it, and that will be the number that I actually use. But they present it in percentages. I might present my answer in percentages, but that is nothing in between. Now that we want to know a question, yes?
So if it was decreased by 20%?
Don't ruin the next one.
Oh.
We're going to do that next time.
Okay.
Because, again, there's going to be no mystery anymore after we're done with all of them. But that is the next one. We need to cover an increase and a decrease. Yeah. But one thing at a time. They ask, what is the area of the new shape? Actually, we've already answered the second part. What is the scale factor is right there. Scale factor. So the questions are a little shuffled around. Scale factor is 1.2. Now let's go back to their first question. What is the area of the new shape? So now I'm using new area. The area factor, I'll do it like this for now. I can't call it scale factor because it's area, but I know it's linked to the scale factor, k squared, times the old area. So that tells me it's 1.2 squared times the original 100 square centimeters, and I get an answer. So don't worry about the calculation, worry about the setup yet again. Answer is nothing? No. Something on your calculator. Read it to me.
Wait, sorry.
I'm not sure about the size of your number, but the digits are good.
14,400.
Really? It's 144. 1.2. It's a decimal point.
Yeah, 14,400.
No. Something went wrong. We're going to look in a second. 140
squared.
All of them. Yeah? Oh. Times 100. Yeah. Times 100.
Times 100 squared, which is...
No. We didn't square the 100.
Yeah, you have a little square above.
That's the units of area.
Oh shit, sorry. I mean, oops.
But it's important to have that figured out now. You don't want that to happen in the test, right? Absolutely.
Okay, that's
Good. 144. We want those things to happen now. This squared is centimeters squared, but it's there, but it's not part of the number portion. Okay, 144. So that's their first question. We've answered the scale factor. Now, by what percentage did the area increase? Well, it's convenient in this case because the old area was 100, the new area is 144, so that means a 44% increase. 44% increase. But notice we don't have to answer that question by looking at the new area versus the old area. It's in here. The scale factor squared is 1.44. That immediately tells me 44 above the base 1, 44% increase. So a 20% increase in the side lengths result in a 44%, 20%. A 20% increase in the side lengths correspond to a 44% increase in the area. So people get confused because they want to take that 20%, that 20 number, to a 44. But that's not how it works. It's 1.2 that gets used in the calculations, which gives me 1.44, which I then take to the percentage interpretation. Thoughts on that one? No thoughts? This is blank. Well, she had her question that we can now look at in the next exercise, 12.5, where I take a shape and I'm given an area. I don't know what the shape is. The original area is 50 square centimeters. I want to design the same shape, dimensions 25% smaller. So the lengths, 25% decrease, which means my scale factor is
0.75.
I like the answer in unison. 0.75, because I go down from my base by 25%, or the decimal version of that. We've got used to those now. So it's a very small step forward. So again, we're just answering the same questions. That's the scale factor, obviously. That's the only thing we call K. Then what we do next, the new area. New area is then K squared times old area. There's no need to call it the area factor, though you could if you needed to. That's 0.75 squared times 50 square centimeters, and I get what I get. Now, see, the centimeter squares won't be in the calculation because it's listed on both, on the number portion. I get whatever the calculator screen tells me because I've done everything, I've set it up, it's just a formality now. I never worried about the calculation until now. What do I get? Maybe something close to 30? My pen has decided it doesn't want to play anymore. It's very mature. Does this still want to play? We have lost all communication with the laptop. We will attempt. We have lost all communications with the laptop completely. Anyway, you can still tell me the answer.
28.13.
28.13. I think the video is not destined to happen. Give it a shot, maybe it's going to come back. It notices it. Yeah, it's unhappy. There's a line there. Okay, maybe we salvaged it. 28, 13. Now the numbers are less convenient for me to look at the new area versus the old area and quickly see the percentage change, but it's in the area factor. It's right there. 0.75 squared is 0.625? 5.6? 5.625. Oh, right, of course. I just did that to test. It's on video forever. So if I can just interpret that area factor, the percentage change referring to the area is already in there. How do I do it? How do I do it? I look at the change from the base 1, or 100%. Yes, I'm giving you options. That's what we did last time. But I could very easily never know the area. I can still talk about the change. We'll see that in a second. So it's good to have the options. If I just use this area factor, I will say here, difference from 1.000, however many zeros I need, is 0.4375. And therefore it's a 43.75% decrease. So how I interpret a factor, scale factor, area factor, whatever, in terms of a percentage, it's always the same. Look at the change from the base. Whether you convert that to 56.25% and then look at the change, that's all the same in the end. All right. Now, these two exercises don't cover absolutely everything. Let's see absolutely every possible combination of information they could give and ask in a test. It's too late in the semester for mystery and surprises. Well, maybe not for you. Feel free to plug your ears. It's always an option. So we have a little table where the things involved are the scale factor, which refers to length, that's the K, as well as the percentage change. Yeah. Back it up.
I'm sorry.
Okay, I didn't see it. I calculated 0.75 squared on your calculator. Or in your head, if you're like a challenge, it's all good. One way or another.
Okay, so that has nothing to do with the other part.
So I was trying to show that I can find the percentage change without knowing the actual areas. If I knew the actual areas, sure, I can look at the 28.13 versus the 50 and calculate 43 as well, but I didn't need to know that. I can get it from the area factor alone. We're going to see it in the table.
And then you do 1 minus that.
Then I always go from the base 1 down in this case. So in this exercise 12.6, I have no idea what the actual areas are. I can still, that doesn't even look like a percentage. Erase. I can still see how the length change and the area change compare to each other. So the scale factor is a length factor, percentage version, the excuse me, area, can't write clearly, area factor, and the percentage change referring to the area, of course. So we have these 4 things that appear in these questions. 1 has to be given, and we have to be able to find everything else. So for example, the first one gives me a scale factor of 1.2. Can I find all the other columns that match that 1.2? First, I will interpret that 1.2 as a percentage change, and it is going to be 20%. I'll put an up arrow because I'm lazy, indicating which way does it go. 20% up, 20% down. It's up in this case. It's an increase. Now to find the area factor, it's 1.2 squared, which we already did, 1.44. And then the corresponding percentage change is 44% increase. Without knowing what the actual area is, I have no idea. I don't know what the shape is, I know nothing. Is everyone happy with that first possibility? In the past, people were not happy about this, so please let me know. The video may or may not work. You don't want to risk it. Ask away. Then I have an 80% given. Now that's incomplete. I have to say, is it an increase or a decrease? Let's go decrease. Mix it up. It's not clear in the book. It has to say increase or decrease. So let's pretend it said decrease. Which column am I going to do first? Scale factor, because that's just an interpretation sort of issue. I can cross over between those hopefully easily. So if I decrease something by 80%, what is the decimal? It's down from 1 or 100%, and I get 0.2. It's so far down, it doesn't happen often, but it could happen. All right. Now I'll use the scale factor to get the area factor, and that's 0.2 squared, which is tiny, 0.04, which means the area changed, a decrease of how many percent? 96% decrease. By decreasing the side lengths of the shape 80%, I lost a whole bunch of area.
How'd you get 96?
I look at the 0.04, which is the area factor, and then I see how far did I go down from 1? 0.96. It's always the difference, the distance from 1. 0.96, then I made it a percentage.
Why did you decide that this was a decrease?
Because we have to know which way did we go. So we just picked one.
Oh, we're just picking one.
The question
Okay.
should have said it.
Okay, gotcha.
The question should have that arrow in there. But it may or it may not. In the quiz question, well. Everyone happy with the second one? So we run down the options. Maybe the maybe the area factor is given. Which column do I want to do first? Percentage. What is the percentage change when it's a 1.2? 20% increase. But that now refers to the area. So to get the scale factor that gives me that area factor, I have to note that the, let's do it like this. Area factor is the scale factor squared. So the scale factor is the square root of the area factor. So here I would get the square root of 1.2, which of course I know, but I'll let you do. 1 point? Let's have a good number of decimals. 0.0954, just in case. If I round too much, it looks simpler than it is, perhaps. So it depends which one I have, which way I want to go. That then means the length increased by 9.45%. Because I go from my base 1, and that's an increase, and I just make it a percentage. Trying to look at all the combinations. That one may be a little bit more difficult because I'm given area. But still, everything's pretty much the same. And lastly, I could be given an area percentage change. Let's go down again. They have to tell me. They should have. So let's pick one. Let's pick the area decreased by 80%. Which column is next? Area factor, which we've seen before is a 0.2 because I went down by 80%. I only have 20% left. Then I go over to the scale factor, which is the square root of 0.2. Which is 0.4473. Oops, my 4 is ugly. And then I interpret that as a percentage. Looking at the difference from 1 down to that will be, I'll do it like this, 0.5527, but then I make it a percentage. So I move the decimal in 2 spots. So 55.27% decrease. Always the difference from 1. We said here, incorrectly, it's an 8. So regardless of which piece of information they give me, I should now be able to find all the other pieces. No? You don't like it?
Oh, wait, never mind.
It's the difference from 1. If I have 44.72% of length left, how much was the change? So that's the rest of it.
Please remember to click the like button if you enjoyed the video and to subscribe if you want to be notified of more videos. Thank you.